Hi and welcome to Engineer's Mindset. Now we have a question on 3 dimension, and the question says a tower guy wire is anchored by means of a bolt at A. The tension in the cable is 2500 Newton. Determine A, the magnitude of force acting on the bolt, B, the angles define the direction of the force. Alright, so let's do justice to this. Now I told us that in applied mechanics there's always a need to outline what is called a free body diagram to all questions that is given to us, as the free body diagram will enable us to be able to do all our analysis easily. So we are going to draw the free body diagram of this and obtain what it looks like. Alright, so I'll take us through the analysis of the free body diagram and let's see what we'll have. Okay, so we have this, so let's get our 3-dimensional line out. Okay, these are y, these are x, and these are z. So let's represent what we have: this y, this x, and this z. Okay, so from B to the origin is simply from this point, so we'll have here to be B. So let's our point B, which is this. Okay, from B to the origin is 80, which is this height, 80. So we indicate that from B to this point, the origin is simply what? 80 meters. So we indicate 80 meters. Similarly, there's a cable that connects point B to point A, and notice that point A is at a distance from X. The distance is 30, so it means we have point A to be somewhere around here. Okay, point A is somewhere around. Alright, so distance from point A, from X to point A is simply 30. So distance from here to this point is 30. So this your point A is 30 meters. Okay, and then we'll have the cable between B to A. So let's join the cable together. Okay, and will be really accurate. Alright, so we'll have this. Alright, so since the bolt is tied at point A, since the cable is tied or bolted at point A, it means tension, like I told you, is always pointed towards the point, or directed towards the point it is tied. So the tension is moving towards point A. So we'll have tension, and this is A and B. So this tension in cable A, B. So you have this. Alright. Okay. Similarly, if you check, there's a distance of the x-axis traveling towards A. This distance is what? 40. Okay, to the x is 40. Alright, so we indicate that. Okay, so from the origin you have 40 towards point A. So from the origin to point A, so we'll have a distance that moved okay, to point A. Okay, so we have this to point A. Okay, and the distance is simply 40 meters. Alright, so that gives us, this is now the free body diagram. Now the first question says we should determine the component of forces acting on the system. Okay, now you know that, recall we said earlier that f of x is simply f cos theta x. Okay, and f of y is simply f cos theta y. Similarly, f of z is simply f cos theta z. So these are the components of the forces acting on the system. But a careful look at the diagram shows that we do not have cos theta x, cos theta y, and cos theta z. And that brings us to what I told us when we talked about resultant force in vector. We said f resultant in vector is simply fx I plus fy j plus fz k, and we conclusively obtain that resultant force in vector form is simply what? Magnitude times unit of unit vectors. Okay, so we obtained earlier that the unit vectors lambda is simply cos theta x in the I plus cos theta y in j plus cos theta z in the k. But whereas we don't have these angles theta x, theta y, and theta z, that means the unit vectors have to be in terms of position. So in terms of position, we now have arrow AB, okay, all over magnitude of arrow AB. So it is clearly stated now that this is now in terms of position. So we have to obtain the unit vectors in terms of position before we can be able to apply this formula. So we are going to use this to solve, but we need to obtain what? The unit vectors. Alright, now I will take you through a very sweet way of obtaining the unit vectors. Here is the origin O, So we'll move from the origin and locate each of the points. We'll have 2 points here. This point A, and then we'll have point B, and this is the origin. So we'll move from the origin to locate all the points. Now this is how we apply it. This is how we employ it. Now, in order to move from the origin, we'll choose the position vector of the origin as 0. Okay, so position vector at the origin is always 0. So use obtain position vectors. So we'll obtain all position vectors. Okay, so RO at the origin, position vector is 0. Okay, so that simply implies that RO is simply what? 0. O means position at O means origin. R is the position from the origin. Okay, if we have that, position vector at the origin is 0, then move from the origin to locate every other point. So I'll move from the origin to locate point B. Now notice that I've always said y is always the j direction in vector, x is always the I direction in vector, of course z is k direction in vector. So if I move upwards, it means I'm going positive to the direction of j, but if I'm moving downwards, it means I'm going negative to the direction of j. So if my position vector implies that I have to move downwards, then it means that I'm going against j, so it has to be minus j. Okay, if I move to the right, I'm moving to the positive x. Therefore, if I'm moving backwards, it means I'm going negative x. That means it's going to be minus I. So backwards now simply means something like this. So you have this to be what? Minus I. Okay, downwards is this. So you have this to be minus j. Okay, so it means if I'm moving this direction, it's positive k. So if I'm moving against that direction, it has to be what? Negative k. Okay, so establishing that, so we now proceed to finding the other position. So let me move. Remember, the position vector at the origin is always 0. Then move from the origin to locate every other positions. So I'll move from the origin to locate point B. I call that RB. So I call it RB. Okay, so moving from the origin to locate point B. If you move from the origin, notice that I move upwards to locate point B. I'm moving upwards. I've covered this distance of what? 80. And 80 in the j direction. So I'm going upwards is positive. Distance covered is 80 and it's in the j direction, so it's positive. So that means I'm going to have that position. RB is simply what? 80j. Okay, if I want to locate RA, position A, RA, also move from the origin to locate point A. So I'll move from the origin to locate point A. So I'll move from this point to this point first, because this is not where point A is. If I'm moving from here to this point, from the origin to this point, I'm moving from this point to this point. I've covered the distance of 40. I've covered the distance of 40 meters in the x, that's I direction, and it's positive because I'm moving forward to the right. I'm not moving backwards. I'm moving towards my right, so it's positive. So from the origin to this point first, I've covered 40 meters in the I direction, so 40. But this is where point A is. So I have to now move from this point to this point. Moving from this point to this point means I'm going in the z, negative z direction. Remember, z direction is supposed to be like this, which is positive in this direction. But I'm now moving from here to this point is positive in the x. Then now move from here to this point, I'm moving negative to the z direction. So which means in order for me to locate point A, I first of all move from the origin to x in this direction, covering 40 meters in the I, so it's positive. So I have 40i, but that is not where A is. A is now from this point I will now move backwards. So I'm moving negative toward the z component. So moving backwards, and the z component is usually k direction. So I move backwards to covering a distance of what? 30 to get to point A. So backwards is now simply what? Minus 30k. So those are the positions. Now obtaining these positions, all right, so these are the individual positions. Okay, so we now have to relate. Of course, the tension is between cable A and B. So we now need to find the position vector between A and B. So since we know that forces cannot move diagonally, forces have to move in axis. That's why we can't just move directly from point B to point A. Okay, so to find the position vector between A and B, we call that RAB. So position vector between AB is simply RAB, and RAB is simply RB minus RA. Okay, and that's simply RAB is simply RB gave us 80J, which is this. So this 80J minus RA gave us 40I minus 30K. Okay, so it now implies that the position vector between A and B is simply what? Okay, 80J minus, okay, minus times 40 gives us minus 40I, minus times this minus gives us plus, so plus 30. Okay, so this becomes the position between A and B. So we can rewrite this position to let it be in terms of IJK. So RAB is simply what? Minus 40I plus 80J plus 30K. That gives us the position vector between A and B. Now, noting the position vectors, we can now find the magnitude of the position vector. So we'll find the magnitude of position vector. And magnitude is what I told you earlier as RAB. Magnitude is simply the square root of the individual terms that makes up the position vector. So the square root of, okay, 40 or minus 40 all squared plus 80 all squared plus 30 all squared. Okay, so RAB magnitude is now equal to the square root. Of course, once you square a negative sign, it becomes positive. So 40 squared gives us 1600. So this 1600 plus 80 squared, 6400. So 6400 plus 30 squared, so 900. So we'll add all that together. Position magnitude of position vector AB is now equal to square root. Okay, we'll have 8400. So we'll find the square root of 8400. AB magnitude and give us 94.34 meters. Okay, so if we've obtained the magnitude, the next thing to obtain is what? The unit vector, lambda. And lambda is simply position vector RAB all over magnitude RAB. Okay, so unit vector lambda is equal to position vector give us minus 40I plus 80J plus 30K. So minus 40I plus 80J plus 30K all over 94.334. Okay, so unit vector is now equal to, this is simply minus 40I over 94.34 plus 80J over 94.34 plus 30K over 94.34. all right, so unit vectors is now equal to, okay, so if you evaluate this, minus 40I divides 94.34, you have this 0.42I minus 0.42I, okay, plus 80J divided by 94.34 gives us this, and then plus 30K divided by 94.34 gives us this. So if we obtain this, it becomes the unit vectors. Now recall that force is equal to magnitude of force times what? Unit vectors. Okay, so the resultant force is simply magnitude of force times unit vector. So in this case, we're talking about tension. So it means now that the vector form of the tension force is simply what? Magnitude of the tension times what? Unit vectors, since we're talking about tension. So this is simply tension in cable AB, tension in cable AB times unit vectors AB. Okay, all right, so we'll obtain this to be unit vectors. Remember, but we were given that the tension in cable AB is equal to 2500 from the question. So if the tension in the cable is 2500 newtons, so it was already given to us from the question. So it now implies that TAB is already given us 2500 newtons. That's the magnitude. All right, so the vector form of the tension TAB is now equal to 2500 newton times unit vectors, and unit vector give us minus 0.42I plus 0.55G plus 0.32K. all right, so if we have this, it means the position vector of the tension force is now equal to, so we'll expand the bracket, 2500 times 0.42 gives us, so that gives us minus 1050 I, okay, plus 2500 by 0.55, that gives us 1375 J, plus 2500 by 0.32, that gives us 800, so plus 800. Okay, so we have this will be the tension force. Okay, but recall, okay, that position vector of the tension in the cable is simply Txi plus Tyj plus Tzk in terms of tension. Okay, so this is what we obtained when we're talking about the analysis of vectors earlier. Okay, we simply say that the position vector of the force is simply Fxi plus Fyg plus Fzk. So we can write that in terms of tension. So tension in the cable is simply what Txi plus Tyg plus Tzk. So comparing the two equations, call this equation 1 and call this equation 2. Comparing the two equations, comparing equation 1 and 2, we now find out that if we compare these two equations, Tx stands for what? 1050 minus 1050. Ty stands for what? 1375. While Tz stands for what? 800. So on comparison, we now imply that, okay, that simply implies that tension in X is simply what? Minus 1050 newtons. Okay, tension in Y is simply 1375 Newton, and tension in Z is simply 800 Newton. Okay, so these are the tension forces in the cable. Okay, so those are the components of the tension forces in the cables. So Tx, Ty, and Tc gives us that. Now the second question says, okay, the angles define the direction of the forces. Okay, so we'll now find the angles. Now to obtain the angles, recall that we said Fx is simply F cos theta x. So this simply implies now that Ts will also be T cos theta s. Okay, and we know what Ts is, we know what T is. So that implies now that cos theta s is simply Ts divided by T. Of course, dividing both sides by T. Okay, Ts divided by T will give us cos theta s, and therefore theta s is simply cos inverse of Ts over T. Theta s is simply cos inverse Ts. Ts give us minus 1050, so we have minus 1050 divided by T. T is 2500. Okay, so this arc cos of 1050 divides 2 was minus 0.12. Okay, so cos inverse of that will now give us that theta is equal to, so theta x is simply approximately 114.8 degrees. Okay, that's theta s. Also, Ty is simply T cos theta y. So that simply implies that cos theta y is simply Ty over T, and therefore theta y becomes cos inverse Ty over T. So this simply cos inverse Ty is 1375 over T is 2500. Okay, theta y is equal to cos inverse of 1375 by 2500. Okay, that's 0.55. So we obtain cos inverse of 0.55. That implies theta y is equal to 55.6 degrees. Okay, also theta z will definitely be cos inverse of T z over T. So theta z is equal to cos inverse Tz is 800, T is 2500. Okay, theta z is equal to cos inverse of, give us 0.32. Okay, so that implies theta is equal to cos inverse of 0.32. Alright, so 71.3 degrees. So those are the angles in X, Y, and Z. That's it, guys. I will see you in the next video with another question on 3 dimension. Please like the video if you find it interesting. Comment if you have any question to ask, and share for more subscribers. Thank you very much. I'll see you in the next video.